What's up, guys, and welcome to another fantastic episode of Off Topic. With me, Sam Paler, and this guy,
Mark Fox Powell. Hi.
Off Topic is Off Empire's weekly show. So, what are we doing today?
Well, today we're going to talk about exploration of space, but specifically about like how we might potentially explore beyond our solar system.
Yeah.
So if that's actually a plausible goal, and how we might do it, and the kinds of systems, the kinds of energies that might be involved, etc., the type of propulsion we might use to get to other stars, and whether we'll ever achieve it.
How we'll travel the galaxy.
Exactly.
Yeah. But first, the Anthropocene has started.
Oh yeah. Shit, I saw that in the news. That's cool.
Yeah, it is.
I think it's cool.
It's kind of scary in a way. So the Anthropocene is like this period of geological history, right?
Yeah.
That represents the time in which humans have been influencing
The geological record.
Yeah. So you split geological periods, like time, into different periods depending on various big changes, and people have been arguing for a long time that humans are causing enough of largely a fuck up of the planet.
Yeah, sure. Like affecting climate long term and in a negative way, causing huge loads of extinctions, like etc.
And these sorts of things will show up in the geological record in many years.
Yeah.
So things like cities, like the concrete deposits from cities, all the plastics, various changes to the isotope composition of the atmosphere that will be recorded in rock weathering, these types of things, ocean water chemistry. Yeah. All that kind of stuff is just almost purely by us. Well, the Anthropocene is us. Yeah. So like, you can look back across geological time. Think back, to all these like big periods in geological time. When you get things like the Great Oxidation Event, which was like the development of photosynthesis.
Huge like increase in oxygen levels in the atmosphere. Yeah.
Like, humans are that bigger. I mean, we know. I suppose it's sort of obvious, but we are that bigger change.
Which is crazy to think about when you try and get your head around that. Like, it's an equivalent change to the surface of the Earth that something like an event like the evolution of photosynthesis was. Yeah. And it might even prove to be a bigger, like a more significant.
Photosynthesis has got nothing on us.
Yeah, got nothing.
We need it, but
we do at the moment. Maybe not forever.
We do without it. You could potentially manufacture an atmosphere.
Yeah, but once we're like super advanced civilization, we won't need any of that shit. We just sort ourselves out in other ways. I don't know. Meet all of our energy demands and like synthesize everything.
If you've got fusion, you
could plausibly do a lot, most things to keep civilization going, to keep people alive. But we don't want that. Like, that would be bad if photosynthesis stopped, because that would mean all plants have died.
Yes, that would suck. We need plants for other reasons as well.
But I mean, I think the Anthropocene stuff is like the cool side of it to me. Is that you could imagine like coming across what was essentially a planet like Mars, like a dead planet that had like signatures of past like water or whatever. Yeah. And if you start examining it and looking stratigraphically at it, so looking at like the layers of like geology and stuff, you might come across like sections of that stratigraphy which are only explained by civilization building. Yeah, which is so we're leaving that signature on the Earth. So even long after like we've all blasted ourselves away through some like horrendous nuclear war, some like other alien civilization would be able to work out from the geological record that we were around.
Well, and potentially a civilization that develops after us on Earth.
Yeah.
So if we die off, and then there's a period of time which we go back to like basic multicellular, possibly even just single-celled organisms.
Oh,
and it redevelops over.
How long is the lifetime of the Earth meant to last? Like from now
till the sun ends, which is like, is that 12 billion years away or something like that?
I don't know.
Can't remember.
I don't think so. I don't think it's that long.
It's not that long.
No, I think it's more like
maybe it's a total of 12 then.
Yes.
Or something like that.
Yeah, I think it's of that order for a star like the sun. It's like 10 billion years. Yeah, in fact, that is the rough lifetime of a star like the sun. Yeah. It's about 10 billion years, I think. So we're about halfway through that, nearly. So there's easily enough time for another civilization.
Especially,
there's even enough time for like multiple, for like a civilization to arise and then destroy itself or be destroyed, and then another one to arise and then destroy itself.
But depending on how much is destroyed in that extinction event.
Yeah.
So if you lose everything down to single-celled organisms, it's going to be a while till you get back to like multicellular life.
How long did it take here? About 500 million years? Well,
depends.
Yeah, it depends where you measure it from. It's so hard to predict these things.
And you don't know how. I mean, you may not develop intelligent life again. Like it might just be chance that it develops at this
of course.
period of time. But you'd think it was likely that if we got wiped out now and a good portion of the biosphere didn't get wiped out, that you would get another intelligent species before the sun destroyed the Earth.
You would think so.
Or the Earth became uninhabitable.
So the other question is, like, what if we are the second?
Well,
there were like dinosaur cities or something we just don't know about yet.
We'd see it in the geological record.
We would.
There's nothing in the geological record that remotely resembles the Anthropocene.
I know.
As far as we know. And obviously there's lots of about the geological record we don't know, but that would be a pretty like big and obvious thing.
It's a ridiculous suggestion. We wouldn't know about it if it happened. It would be like a really weird anomalous part of the record that is like, what the Christ is this?
Yeah, exactly.
Which is, there's mysteries there obviously, but nothing like that, nothing of that scale.
Yeah. So I guess we're just going to we're just now in a different geological era. Yeah. And we're controlling
the Anthropocene. Yeah, and it's probably. Do you reckon it's going to get more significant, like that impact? So that we're, these are the early days of basically the human influence on the planet, and it's just going to get more so. Or do you reckon we're going to start being less impactful as we develop ways of like lower emission vehicles and being more aware of like the impact we're having?
We might end up being less impactful.
So you think it's going to like peak?
But in different ways. So it will peak in terms of possibly our alteration of the atmosphere, our change of the oceans and stuff. But in terms of like building structures, I don't think that's gonna get worse, presumably.
Surely, as the population grows.
Yeah, although the population will flatten out at some point, probably.
Yeah, but not yet.
So I don't think it will peak. It's not peaked. No. There'll be a time when there's more structures built on Earth. And so
when Earth looks like Coruscant.
We don't want that though.
No, we don't.
But there'll definitely be there's still a lot of expansion happening in developing countries around the world.
Yeah, massively. So, like cities are growing at like a record rate all the time, and blah blah blah.
So we will change it more, but I feel like we're starting to realise how much we're screwing it up. That doesn't mean that we can we're not in a lot of ways not stopping.
And there might be something that we haven't, like not an unpredictable, but like an unforeseen event, like for example the development of AI, super intelligent AI.
Oh, of course.
Just totally. I mean, that even could be arguably like a whole new geological. What the effects that like machine intelligence would have on the geological record might be different, measurably different. To what humans do. I mean, who knows? That's all like speculative.
Yeah, that's like even that change is a bigger change than developing intelligent like human life. Yeah, potentially.
Yeah, potentially. Yeah.
To the point where like it's the difference between life and no life. Like there's a jump that's that big, or even bigger. I mean, you could just cover the Earth in machines or whatever. So. Whatever.
Yeah, I mean...
It could totally change the geological record.
Yeah. Your imagination is sort of like the limit there.
Yeah.
You just can go mental.
Exactly.
But, it's cool.
The Anthropocene's cool.
It's cool. It's scary, but cool. It has, like, possible bad connotations, but it's interesting.
So, main topic. Which related to the Anthropocene, because if we can move the Anthropocene to other planets, like change the geological history of other planets using our technology that we've been building over the years. So right now I think we're going to go through kind of some of the different things that we currently use and kind of ask a few different questions about, where we are with space travel. Yeah. And how that might change in the future. Yeah. So to start with, what do we use now? So most of the rockets we use are just chemical rockets, right?
Chemical rockets, so you just basically burn chemical fuel, and that creates thrust, just because you're like spelling out like a shitload of propellant out the back, and pushes your rocket forward. And that's basically the main way which spacecrafts have always gone around.
Yes.
Both like from the Earth into space, and also like around the solar system, and to get places.
Well, all of them go into space that way.
Yeah, every single rocket goes into space that way, but most travel around the solar system in that way as well.
And we might actually do an episode about access to space.
Yeah.
The different methods like space elevators, that sort of stuff, which is cool and interesting. Yeah. And some of the stuff we're going to talk about today actually relates to that.
And it gets pretty mental.
It does get a bit mad. Yeah, and obviously we're changing the ways we access space with these reusable rockets and things, but they're still just chemical rockets. They're just like much more advanced.
Yeah.
But once we get into space, we've traditionally used chemical rockets, but then they've kind of we still use chemical rockets and we have done for a while. Now we started developing much more fancy pants kind of types of propulsion that are actually pretty shit in atmosphere.
Yeah, they're basically pointless in atmosphere. You couldn't use them in an atmosphere, really.
Yeah.
Like ion thrusters. So things like ion thrusters. So there's like a spectrum of space propulsion. On the one end is like chemical rockets that have what's called a low specific impulse, which is basically just like efficiency. It's just like fuel efficiency.
It's like miles per gallon.
Basically, like how much thrust can you get out of a given amount of fuel. So rockets have really low efficiency in terms of you can get shitloads of thrust, but you need a shitload of fuel to do it.
Yeah.
And then ion thrust is the other end, which you don't need much fuel, but you get tiny amount of thrust. They take ages to accelerate, and they.
Yeah.
But once you have spent ages accelerating, you can be traveling really, really fast for really small amounts of fuel.
Yeah.
So it's like those are the kind of two extreme at the moment, the two sort of end members that we've got.
Yeah. And so, like an ion thruster, if you have an ion thruster, apparently the pressure of it, like the amount of force exerted, is similar to having like a piece of paper like sat on your hand.
Oh man.
So that's how little thrust it produces.
Shit.
Yeah. But because you said they've got very high specific impulse, i.e. they very, very, very slowly run out of fuel, so you can leave them on for a very long time.
And these aren't just like drawing board things. Like the Dawn spacecraft that went to Ceres was ion thruster powered, and it was traveling super fast when they got there. Like I don't know how the numbers, but really fast. And like one of the deep space probe, Deep Space One.
That was the first one that had an ion thruster.
The JUICE mission, which is a terrible name for a mission.
The Jupiter
Icy Moons Explorer, which is a European mission going to Jupiter in like 10 years? 2022.
Is it definitely funded?
Yeah.
No.
That is flying to Jupiter using using like the most efficient ion thruster that's ever been designed.
Yeah,
so these things are like in action and working and
it's like twice as efficient seemingly as the ones that we've seen before, right?
Yeah,
it's something like mega close to.
The specific impulse is basically really high, which means that you need hardly any propellant to get like thrust out of it.
Yeah. And then they're developing those new. What do we call them? Oh, I've forgotten the name.
Oh, the magnetoplasma dynamic rockets. Or something.
Yes.
Okay, so the two ends of the spectrum, chemical and ion thrusters, the two ends of the
they're the two main
spectrum.
Now the two sort of areas of use, aren't they?
Yeah. So what you really want, so both of them, one of them has like a huge requirement for fuel. One of them takes ages to accelerate to high speeds. So that what you want is something in the middle that you can accelerate quickly and everything, but doesn't use like the huge amounts of fuel that the chemical rockets use. And so there's a company called Ad Astra. There's other people developing them as well, but Ad Astra are like just been funded, like given like a shitload of funding from NASA to develop this, make it space ready.
Yes.
This technology, and it's cool. Like the actual engine they're designing is called like VASIMR or something. It's a really bad acronym.
Yes, I've heard of that. Yeah.
It's basically similar to an ion thruster in the sense that you create like a plasma, you get like an ionized gas, force it through like a magnetic field and heat it up to like millions of degrees. This is the difference. You heat it up to ridiculously high
I was about to say that you don't do that with ion thrusters.
You don't do that with ion thrusters. They're cold. Yeah.
Wait, are they cold? No, you still produce a plasma.
Yeah, but it's the plasma's created through like electromagnetic fields rather than heat in an ion thruster. Right. So it's cold. It's a cold plasma, whatever that means.
That's cool.
It's basically just not super hot.
Yeah.
So this one, the cool thing about it, the different thing about it is that instead of like firing your plasma through a metal tube that would get like ridiculously hot, and you're limited by how hot your metal can stand, what temperature your metal can stand, this one is contained by like a magnetic field. So you can raise the temperature of the plasma to literally millions of degrees, which means you can get a shitload of thrust out of it because more temperature, more energy, more thrust.
That sounds a bit like a fusion reactor, like a stellarator.
Yeah, it does.
Because they do something similar, don't they? They basically confine a plasma with a magnetic field.
Yeah.
And try and get it hot, the plasma hot enough to produce fusion.
So there seems these kind of like technologies that use like plasma contained by a magnetic field seems to be like quite a cool thing that's popping up in a few different places.
Yeah.
But yes, anyway, so this thing is going to be.
Where does it fit in the spectrum of?
So it I think the VASIMR engine or whatever it's called, the point of it is it has a variable specific impulse. So it's like it's depending on how much power you put in to heat the plasma, you can get like either better efficiency or worse efficiency out of it. So you can use it as like a long distance, like low efficiency but like very low propellant requiring thing, or give it a bit more propellant and use it for like shorter, much faster journeys.
Yeah.
You just need more power.
Yes.
Yeah. So people are talking about apparently. So it's apparently about being about 10 times faster than chemical rockets at its full power, and using 10 times less fuel, which is what the numbers they're pulling out of like.
That's like the theoretical.
That's the theoretical maximum of it. They're talking about getting to Mars.
10 times faster is ridiculous.
10 times faster. Yeah. They're talking about getting to Mars in 39 days.
Jesus.
But you need an insane amount of power apparently to drive it. So some critics of it say that the getting to Mars in 39 days is just a pipe dream, and you need like more nuclear power than, twice as much nuclear power, because that's the most efficient way to generate electricity.
Yeah.
That we know of. You need So you need like twice as much as like the most powerful nuclear submarine that's ever been built, or something like that. Yeah,
right.
Loads, like a stupid amount to get that kind of speed.
Okay, so it's actually realistically, it's not going to be that. No. You're not going to be blasting a nuclear submarine-sized nuclear reactor into space, let alone 3 of them or whatever.
Yeah. But it might be good for.
But it was still going to potentially reduce the time going to somewhere like Mars.
Yes, and the cost and the amount of propellant you need and all that shit.
Yeah.
But what is probably going to be really good for is like working as like a tugboat almost, like, so saying like space mining, like asteroid mining, like ferrying stuff back and forth like cheaply and quickly. They say that they're actually going to fit an engine, one of these engines, to the space station and use it to like compensate for drag. The space station has like its orbit gradually decreases and they have to keep boosting it back up to speed.
Yeah, it degrades.
They do that chemically now, but if you have one of these things, you can do it like for like a fraction of the cost and all that. So that's going to be a useful application of it.
Yeah, because you could mount it on something like when we were talking about the kind of the ferry, the Mars ferry that goes back and forward. If you need to correct for things or orbits and stuff, you have one of those on there. You potentially have a long-term fuel supply, etc.
Yeah.
And you can make drastic corrections if you need to. I don't know. Yeah, maybe it'd be useful for that. Maybe you just use an ion thruster for that though. Yeah,
I don't know. I mean, you can get a lot more thrust out of one of these.
But you might not need the thrust.
Yeah, true.
But like for ferrying things, you'd want that quick.
Yeah, you want that quick.
You don't want to be waiting months while the ion thruster like gently pushes something around, because you want profit, you want cash.
A tiny little bit, like a piece of paper on your hand, like I'm at thrust.
Yeah, you want to ram it up to high speed, get it off, and keep and also have the efficiency to keep ferrying.
Yeah.
So you don't keep having to like refuel it too often.
Yeah, and they're talking about using these kind of spacecraft to like clear up space junk and that kind of stuff, like zipping around in sort of Earth orbit type altitudes, and with little propellant, and using solar power to generate the required energy.
So when was this thing announced? It was announced really recently.
The funding, the NASA. So the news about it was like like $10 million NASA have pumped into this company to develop it, which is, it's actually not that much really when you think about it, but
no
recently, so like
but
the
10
last
million
couple of weeks,
like is enough to, it's like good Seacorn funding.
Yeah. I think the point of it is you have this thing called technology readiness level in space technology, so they want to get that technology readiness level up to a point where they could plausibly launch like a demonstration engine to the ISS. That's the idea. That's what the $10 million is for.
Yes.
So that was announced, in the last couple of weeks or something. But that's one to keep your eye on.
Yeah, because that fills the middle gap.
It does fill the middle gap,
in our sort of near-term space exploration.
Yeah.
I guess another thing that might sort of fill the middle gap, which is still a chemical rocket, but it's nowhere near the same as it. Are those like? I thought Blue Origin and SpaceX. Well, but Blue Origin was supposed to be developing like a long-burning methane engine. Right?
Yeah, they are. Which is cool. Which is a beast.
But where does that fit in this?
Well, it's still a chemical rocket, so it's still like
it's still
down
high
the bottom.
thrust,
It's still high thrust.
Impulse.
Yeah, exactly. Low efficiency because it's a chemical.
Right.
But it's going to be, the actual numbers on the specific impulse figure aren't really known because they haven't actually built it yet.
Yeah. Okay.
But it's going to be delivering like, I think the numbers are like, 2,500 kilonewtons of thrust. Right. I just looked that up, but that's like
2,500 kilograms.
2,500, which is like 3 times the SpaceX Merlin engines, which are currently on the Falcon 9, which are really powerful.
Right.
So it's a lot of thrust, basically.
Yeah, how powerful are they? They have 9 rocket engines on the Falcon 9.
Yeah, for redundancy.
Yeah, okay.
But the rocket engines themselves are pretty powerful.
Are they? Okay.
But they're just a good, like, they're not like the most powerful things ever. Or
No.
They're not like the Saturn V's.
No.
But they're a good like benchmark figure for for modern chemical rockets.
Yeah.
And these things.
So they're a lot more.
Blue Origin on engines, which actually have been bought by ULA for the Vulcan. That's what the Vulcan is launching on. Well,
that was one.
Will be.
Might launch. That was one of their unique selling things, wasn't it?
Yeah.
They would have these longer term burning engines that are much more efficient.
Yeah.
Can recover fuel or energy or something like that. They can do something.
Are you thinking of the second stage with this like internal combustion thing?
Possibly.
So that's slightly different. I mean, they might be using the same engine, but the point of that was that you can recycle some of the oxidant by using a compressor, an onboard compressor, and keep it burning for longer.
Isn't that part of their whole like engine structure though? Is that it's very high thrust and stuff, but
but also you can burn for a really long time. Yeah.
And so that architecture gives Vulcan something that potentially the Falcon Heavies might not have, or whatever. For now, yeah.
I mean, that's a really good idea. Like keep recycling the oxidant so you can keep burning for longer.
Yeah.
That's a really good idea, and you can, it's the kind of thing that like SpaceX will probably be like, oh, well, we might do that now.
Yeah, of course, yeah.
Because you can have your little second stage in orbit, and you can ferry it about like from different points. You can refuel it. You can keep going. Like, it's essentially like an orbital spacecraft then that can burn multiple times and change orbit and all that kind of shit, which is wicked. It's really cool.
Yeah, that's cool. That's cool.
So those hench Blue Origin engines. Have you heard of the Raptor engines?
Yeah, we talked about them when we talked about the Falcon X. The BFR.
Yeah, the big.
Someone reported that as the big freaking rocket.
No, it's definitely the big fucking rocket. It actually is, like, that's how SpaceX refer to it.
Yeah, I imagine it's going to get both of them. One reported in like the kind of mainstream media as the big freaking rocket, and then on blog posts, YouTube, etc. It would be what it actually is called.
Which is going to get renamed at some point.
Yes,
probably to some badass.
The Falcon
SpaceX
X is pretty cool.
That's a cool name.
That's pretty cool.
Stick with that. With Raptor engines. That's fucking hench.
So what are they compared to the Blue Origin one?
So the Raptor engines, when they eventually get built, so just in terms of thrust, I just like this because of the numbers are mental. The Blue Origin engines are remember the 2,500 kilonewtons, which is about 3 times the amount of the current Merlin engines on the Falcon 9. The Raptor engines are going to be 8,500 kilonewtons, which is another increase of like 3 times above the Blue Origin ones. So they're going to fucking smash them out of the park.
Are they the biggest engines ever?
I think so.
Made?
They will be, yeah. And they're probably only the tip of the iceberg for what SpaceX have planned.
Why?
Because they want to fucking launch that big fucking rocket thing.
But isn't that what the Raptor engines will do?
Yeah, okay. Probably a shitload of them. Yeah,
just a bunch of them like stuck together, like the Falcon 9.
But Raptor are like a rocket engine family, and that number is from the first generation Raptor engines.
Right.
So who knows what else?
You have to go and see one of those launch because it'll be like unbelievably loud.
Yeah, you already like measure like seismic activity from rocket launches, but that is going to like create an earthquake.
It might like knock the wind out of you almost.
Yeah.
Like the when you at like a loud music concert, you've got that like deep bass throbs.
I love that feeling. It's awesome.
But that's gonna, or like if you see like a jet fighter fly past,
and it hits you like deep inside.
Yeah.
Like sort of slightly wins you a little bit.
Yeah, but like, what the hell's a Falcon X rocket taking off going to be like?
I mean,
and when it lands as well.
If it's like, lands, oh my god!
Because with the sonic boom and all that stuff as well.
Jesus,
it's going to be fireworks.
It's going to be dirty. It's
going to be filthy. Yeah, for sure.
It's wrong. But yeah, so that's some cool shit to look forward to, and those things are obviously going to get incorporated into like massive rockets in the future. But anyway, so they're still chemical.
Yeah.
Give you a lot of thrust to get out of Earth's gravity and get you going fast nearby.
Get you out of the atmosphere. Get a lot of mass out of the atmosphere.
Exactly. Yeah. But so the chemical rockets, ion thrusters, and these magnetoplasma thingies, whatever.
Yeah.
They are good for getting around the solar system. They're okay for getting around the solar system. We're the best we've got.
Yeah.
But where does it like fit into? How does that help us with interstellar travel?
Well, it doesn't.
Doesn't
Essentially, we're we're waiting on more developments in order to get out of our own solar system.
Yeah.
We have to develop a new way of traveling, there's a possibility. No, it's not really a possibility. It's probably not going to happen. But there's a chance that we actually can't travel that close, or in like large fractions of light speed.
Yeah.
And so we're always stuck traveling at sort of low, like 0.006.
Yeah.
Of light speed.
Yeah.
Which means we basically have to kind of reevaluate how, if we're going to do it, how we're going to do interstellar travel.
Yeah.
And that would unfortunately require very long time periods.
Hugely long.
Generational time periods.
I mean, I don't even know if people might not have a general idea of the scale of the solar system. You should go, like, there's plenty of like things you can go and check out that give you that sense of scale, like either like on a diagram or like things where you can actually zoom out from the sun at light speed and see how long it takes light to travel the distance. And the solar system itself is massive. To get to another star is just like an unbelievable. You can't even hold that distance in your mind. It's just unbelievable amount of distance.
Yeah.
To get to even the nearest star.
Yeah, it's ridiculous. So to get to the Oort cloud is miles.
Jesus Christ! I know. Actually, that blew my mind a little bit when I found out quite how far away the Oort cloud is.
Yeah, because like when you zoom out, the star, the sun is just a little dot, but the orbit of Pluto is almost like a few pixels.
Yeah. And
the Oort cloud's kind of like a beach ball sized thing.
Yeah.
That's like, what? I thought the Oort cloud originally, when I didn't actually know anything about it, was quite beyond Pluto.
Yeah, just a bit further than Pluto.
It's absolutely miles away.
So there's this really cool way of sort of visualizing the scale of the solar system that I heard, which is a bit mental. So imagine like a coin, like say like a British penny, which is a little bit bigger than an American dime, I think. So
yeah, okay.
It's just like sort of smallish coin.
Yeah.
And that the outer rim of that is the orbit of Neptune.
Yeah.
Right. So imagine so then you can go in from there and like. It's not to do with like the actual orbits of the inner planets. So forget that. They're just in there somewhere, like close to the sun, which is at the center.
Yeah.
Orbit of Neptune is the outside of the penny.
Yeah.
So then imagine if you took like your finger and drew a line right around the edge of the coin, like so your finger's touching the coin. That would basically be like the Kuiper belt. So like all the icy objects, a bit like Pluto, that are just sort of embedded in this ring.
So the thickness of the end of your finger.
Yeah, like if you dabbed the tip of your finger in paint and then just painted a circle around the edge.
Like a thick line around the edge.
Yeah.
Yeah.
That's the kind of like thickness and the scale of the Kuiper belt.
Yeah.
Right?
Yeah.
The Oort cloud would start, it would be a sphere for a start, not a ring.
Yeah.
And it would start 3 meters away from the coin and extend to 30 meters away.
Oh, what?
It's absolutely mental. So if you and on this scale, Alpha Centauri, the nearest star, would be like, imagine like a football pitch. Yeah. One coin at one end and the other coin at the other end. So the Oort clouds would almost like be interacting with each other.
Almost overlap.
Almost, yeah. On that kind of scale, which is meant. Okay, the Oort clouds essentially still just a theory, right? It's not. Yeah, it's just sort of inferred.
It's inferred from the Kuiper belt objects and things. Yeah. It's basically, if you don't know what it is, it's just a load of like dust and old rocky bits from the start of the solar system that got blown out.
That are still just about captive to the sun's gravity.
Yeah.
Just about.
Yeah.
I mean, at that distance is really faint. And travel much further and you're basically in the gravity well of another star.
Yeah. So the Voyager is nowhere near the Oort cloud. No. Nowhere near.
It's still going. It's still accelerating, isn't it? Is it still accelerating?
I think so.
Yeah, I think so. So it's just, and it's like I can't even remember, like 1/7 of the distance, or is that might even be a massive over exaggeration?
It's nowhere near.
It's absolutely nowhere near.
And that's been running for. Well, I know that's obviously old technology, and it will get overtaken by New Horizons.
Yes.
Fairly quickly.
Which is travelling at a pretty fucking fair old rate.
Yeah. And obviously, if we're going for interstellar travel, if we're thinking nearest star, then it's a few light years away, sort of thing.
Yeah.
And that's going to take, with the technology that we have now, just obviously more than like a human lifetime.
Way more. I mean, even like New Horizons at that speed, it's going to take thousands of years to get to the nearest star.
Yeah.
Which is.
So you'd have to develop like basically like a ship that is Earth.
Yeah.
Like essentially, and just live generations of people on that ship.
So if that is reality, if we are just limited to like a fraction of the speed of light. Very fast, but still, very, very limited in terms of speed. If that is the reality of our technology, then yeah, I mean, you're gonna have to. There's two options basically. Either you have a ship that is multi-generational, and seriously multi-generational, because you're talking like thousands of years.
Yeah.
Like, what the hell? You're gonna have like whole cultures like rise up and fade away, and it's
that's a cool.
They'd forget that they're even. Arguably they might forget that they're even from Earth.
They might form like a cult that like worships like the sun they're going to or something.
Yeah, and all the stuff about them leaving Earth behind and
be like
and going
passed
on a
into
mission.
like mythology almost.
Yeah, exactly. Some people would believe it, some people wouldn't.
And you'd get sections, because the ship would have to be so big. You'd get like sections of the ship potentially that would like develop its own separate like cultures and like you might get a civil war on board.
Yeah.
So there's no guarantee it would even get there.
No guarantee it would even get there, and it might even be that if that is the case, that we would decide that robotic exploration, that we just send out probes basically. If it's going to take thousands of years,
but you've still got to think about doing it, because our sun won't last. If we can live at that long,
that's true.
Obviously, that's like in millions of years, billions of years, and if we're still around, then we're gonna have like mega advanced technology. But we're hypothesizing at the moment under the assumption that although we're gonna have loads of advanced technology, actually we still can't.
Yeah, we're still limited to essentially
relatively slow
travel.
Then you're still gonna have to try it.
Yeah,
because you've got to go somewhere.
The other potential thing, and this is science fiction at the moment, but it might end up being something that is possible, is to somehow put people into like a suspended animation or like a stasis or something like that. So that you don't have to have multiple generations, and you can send the crew and wake the same crew up when they reach their destination. Yeah. Thousands of years later.
But that is just like totally science fiction, of course.
Totally science fiction. Yeah, absolutely.
There's no. I mean, there's people talked about like getting people to sort of basically hibernation states, and leaving them for very long periods of time. Like some animals can go into. Yeah. But
aren't there ways of like freezing tissue that doesn't cause like damage to it though?
Yeah, but it kills. There are, but it would kill a human, right? Yeah. Because your body temperature would go too low, and you're.
Yeah, but if you could do it quickly enough, so I think the reason you die at low temperatures is you don't get enough oxygen quickly. You don't metabolize fast enough. Yeah. I think. Well, one of the things that happens.
Yeah. Well, I mean, and if you don't freeze properly, then you end up with crystals bursting all the cells and all that sort of stuff.
Yeah, and then you're totally fucked. You just turn into like jelly when they defrost you. But yeah, like maybe there are ways of like somehow freezing somebody and then thawing them out and they'll be okay. I don't know.
I mean, quite possibly.
Yeah, I mean, we're talking crazy science fiction shit here.
But that would be a way to overcome it if you could do that. You might, for example, in billions of years, that could potentially be a piece of technology if you that would maybe develop. Yeah. Perhaps.
You still have the weird thing of like sending out a crew for thousands of years to reach a destination, and they wake up thousands of years later, and Christ knows what's happened on the Earth in that time.
Well, they're
basically on their own after that.
Yeah, I mean,
see you later.
Exactly. You're seeding the human race.
Yeah, so you sort of still have to send a huge ship with a huge amount of people. Yeah, it ends up being a sort of the same as a multi-generational ship. It's just that the multiple generations don't happen on board; they happen when they
which might be less risky though.
Yeah, sure.
So it's a potential way around some of those problems.
Yeah. So either way, it would kind of suck if we are limited to slow,
it would
slow
suck.
Speeds.
It would definitely suck. But people have come up with ideas, haven't they, to kind of overcome some of these problems, which are mostly science fiction, mostly.
Well, they've been taken seriously though.
Yeah.
So these are ways of. So at the moment, like as far as everything we understand about the universe, it's impossible for anything that has mass to go as fast as or faster than the speed of light. Yeah. But it might be possible to get very, very, very close to that. Yeah. With
like 0.95.
Yeah, with fairly like conventional technology, and with some more mental stuff, which we'll go on to in a minute.
Yeah. Recognizable technology that we might end up using on the Earth to generate power.
Yeah. So I don't know like what kind of speeds stuff like Voyager and things like that or New Horizons get to, but I mean it's like 0.0000. It's like a tiny. It's like
0.006 of light or something like that.
Okay.
Or maybe less.
There you go, 0.006.
I can't remember exactly. Something like that.
Yeah, less than 1, but very low.
Yeah.
But there are other ways of getting faster, right? One of them
is brilliant.
Never been done, but been talked about quite a lot.
And the reasons not been done are really funny.
Yeah. That's
well,
good.
they're pretty funny.
Good.
So
high quality.
One of them, which I'm pretty sure is like is a defunct idea now, is to basically, which is like the answer to a lot of things, seemingly, it's basically just nuke it. So you just set off like streams of nuclear bombs behind
one after another.
It's a great idea.
It is a great idea. I've just got this image of like people just like chucking bombs, like bang, another one, chuck it in, bang. But yeah, you just have this rhythm of essentially nuclear explosions at the one end of a rocket, and you direct the force of the nuclear explosion.
Yeah, and you have some sort of shield.
Yeah, you have a shield which absorbs that force and propels your spacecraft. And you can, if you fire them at a regular kind of cadence, you can speed up to ridiculously high speeds, like way faster than you can get with chemical rockets or ion thrusters or anything.
Yeah, so they actually banned development on this happening, right? Because, but I don't really understand this, but it was because they wanted to get into, they were going to let them off in the atmosphere and try and basically see if they could propel something along with nuclear bombs in the atmosphere, propel something into space.
Yeah.
Obviously, you could just stick something up with a conventional rocket and then start trying to nuke it around.
You could, but there's another treaty which says that you can't let off nuclear bombs in space. So basically...
So the whole thing got banned.
Yeah. Which, is probably a good thing, but I would love to see a rocket taking off with loads of nuclear... Apparently one of them...
It would be funny.
Yeah.
Like, as long as it's away from causing harm. Like if Voyager was just letting off loads of nukes behind it, it'd be well funny. Well cool.
It'd be amazing.
You could watch them in like telescopes, just like...
These things are like, they had ridiculous stats. Like you'd have to take like 30,000 like bombs with you or something to like reach Alpha Centauri to get a high enough speed.
And how far behind? Because obviously a nuke's just going to destroy anything that's like close to it. So they've got to let them off quite far behind it. It's got a shield, but like something to stop.
So you mean like where the crew sit and where the engines are,
or just not
engines.
Doesn't
even feel right calling them engines. Like it's like the bomb place,
the bomb shelter,
the bomb shelter.
Like the shield. What's the shield going to be made of to deflect nuclear blasts and stuff? I suppose when you let off a nuke in the Earth's atmosphere, you can have like fallout shelters and stuff that would stand it.
I don't think the shield.
And wouldn't the acceleration be like nuts? You'd be like just potentially like hundreds of G's like acceleration.
That's one of the problems with it. You had to have these like really crazy shock absorbers to stop it having these like impulse accelerations and to sort of somehow like transfer the energy of the explosion into the rocket in a way that's okay for human. I don't really get it. It was very complicated.
This is Project Orion, right? Or yes. This is one of the
Project Orion.
But other ideas.
There are a few others. There were a couple that were actually like honestly developed for, they were gonna start building prototypes. They had like a program developed around them. Project Orion is one of them.
Yeah. Which is, it's good fun, but the more you think about it, the stupider it is.
Yeah.
Because like you can't really accelerate something like. How are you gonna put shock absorbers in? Like how big are these shock absorbers? Like hundreds or thousands of kilometer long springs to kind of like push this thing in like a gentle and then it would start like retracting back and
the size of these shields as well had to be giant, like they were huge for some
and made of something incredibly strong.
Well, I don't quite understand it. I was reading about it and I don't think they have to be. They can be quite because they're, especially when you're in a vacuum, like the explosion will push that forward, but it won't necessarily damage. It's not pushing against anything else. It's not like it.
Yeah, it's not hard compress. There's not going to be a shockwave.
Exactly. Yeah. So it's literally just the explosion happens and you just fire this thing forward, and the shield's just there to like capture as much of the force of the blast as possible.
Okay. So actually, it's not that destructive.
No, but launching it from the ground, like surely, I don't understand. Surely that's just going to tear it apart.
You'd have to build it in orbit, wouldn't you?
They were talking about launching one of these. Project Orion was meant to be launched from the ground. One of the things it could do was a single stage to Mars and back. That's what they were talking about doing. Just a big fuck off rocket. Blow up some nuclear bombs underneath it, and it gets to Mars, lands on Mars somehow, and then comes back. And only one stage.
Just by nuking its way across the solar system.
I love it.
But it's got to slow down by nuking as well. So it's just like chucking bombs at Mars, trying to like... it'd just be crazy. But then I suppose you do some aero braking.
I guess. I just love it because it's just the concept.
And how do you land on nuclear bombs?
I don't know.
Like it'd just be coming through the atmosphere, just nuking its way down, like riding these like ludicrous cushions of explosions. I don't know if you get like mini nukes that kind of.
Yeah.
I don't know.
That's the answer to everything is just nuke it.
Exactly.
How do you slow down? Nuke it. How do you speed up? Nuke it.
That's why it's great. That's why it's a thoroughly enjoyable idea.
Yeah.
But there are slightly saner, maybe not saner, but slightly less crazy ideas.
Right.
Maybe they're not less crazy. I'm not quite sure if they're less crazy. They're basically using like fusion.
Like nuclear fusion. Okay.
And there are ideas to produce using like I think they might have been fusion bombs as well, like Project Daedalus.
Daedalus. That's what I'd say.
Yeah.
DAE. Daedalus.
Daedalus. That thing. Where they basically the idea with that was to get to another star. It was like a design they built.
Yeah.
And I mean, it was. I think it was get to about 12% the speed of light.
Jesus.
But it had like multiple stages.
Right. 12% speed. I mean, considering like New Horizons, which is the fastest spacecraft ever made.
Yeah.
And it's like screaming through the solar system right now.
And it basically
it's going 0.006, whatever you said.
Yeah.
0.06.
It took on like a load of fuel and then had to basically like laser compress a bunch of like fissile fuel pods and drop them out.
So it's kind of like explosions in the same way.
Yeah, but it's much smaller.
Yeah. It's not literally just like setting off bombs behind the
No, it would have had like what would have resembled a normal looking sort of engine at the back. And in the like combustion chamber, it would have been like these plasmas coming out of fusion reactions.
That seems like quite a good idea.
Yeah, it would have been highly expensive, and it was absolutely massive, like 450 tons.
Yeah.
And it went through like different stages of like it would happen to be going really, really fast. It was the aim of it was basically to get to Alpha Centauri. Okay? Right. It was like come up with a design to get to Alpha Centauri. Yeah. And they had all these ideas, different ways of doing it, and they realized you get to like 12% the speed of light. Okay.
Yeah.
Doing the maths and bringing all this fuel, but then you can't slow down. So what it would do was drop off a bunch of like probes. So the spacecraft itself would basically just go past and do nothing. Okay. And as it was approaching Alpha Centauri, it would use telescopes on the spaceship to search for like planets and things of interest, and then it would launch a load of probes that then like went to those points of interest and slowed down. Yeah. And
so what happens to the ship? It just like fucking tears
flings
through,
off
and that's it.
And goes off.
See you later.
But it was like 450 tons and like 40-something thousand tons of fuel, like huge, just a ridiculous like engineering project. And to make the fusion work, they had to get helium-3. You can find it on the moon,
right?
But they were thinking one way to get this. This was like in the plans, was to get an air balloon over Jupiter and like have a station that scoops hydrogen out of the top of Jupiter's atmosphere and collects it and like builds up enough of this helium to helium-3 to fuel the thing, because there's so much of it, so much mass you needed of it.
It's just ridiculously complex.
Exactly, totally unaffordable. Yeah. A ridiculous idea.
It's almost just an exercise in like how it's not possible, in a way.
Sort of, yeah.
It's like if this is what we've got to do, then like maybe forget it. But 12% the speed of light. So if Alpha Centauri is 4 light years away.
Yeah, I think it was.
So if you travel
50
at
years
the speed of light, it takes 4 years. So 12%, yeah,
something like that.
so you could do it. You could plausibly do it in the lifetime of a person in this thing.
Yeah.
It's okay, but I don't want to be stuck in a spaceship for 50 years. So it's still not quite. It's still not fast enough.
No, it's not really fast enough. There have been other ideas, like Valkyrie, Project Valkyrie, which
is that antimatter thing?
Yeah, and it actually uses a similar type of idea in a way to the other one, which it would use fusion, except for the fusion was set off instead of by lasers, which meant you had to have loads more electric energy and stuff on board.
Of course.
You set it off by basically injecting like a piece of antimatter into the middle of some fissile material. Yeah. So like just like an antiproton or whatever and that would instantly react and cause a fusion reaction. And so you have it burning that to get up to its speed. So it's not using much antimatter, which is really hard to produce.
I was going to say, how do you produce antimatter?
It's like just you can do it in like accelerators and all sorts of different ways.
Would you have to have an accelerator with you?
Potentially.
Or can you store antimatter?
Well, there's ways you can do it. If you have enough electricity, you can do it basically. But the electricity it needed to produce the amount of to get, I think it was about 50 tons of fuel.
Yeah.
And it needs about 100.
Right.
Would be, I can't remember how many joules it was because it was like 10 to the 26 or something ridiculous, 10 to 17. Wow. It was basically the amount of electricity that humanity has consumed over the last 40 years to produce the antimatter to propel 50 tons, and the design it was for about 100 tons.
So it's basically just completely not plausible at all.
Well, the idea is that you could, if you have fusion reactors, very good fusion reactors, that you could produce antimatter for the main drive on board. And we obviously in 40 years, like if you potentially have like an exponential increase in power. So actually, if you have very, very efficient, very good fusion reactors that you fueled previously before to produce antimatter on board, it's ridiculous, but maybe with if we get a breakthrough in fusion that actually works, possibly you could produce it. The other idea is they have like a giant solar farm,
right?
Which would again,
what do you take with you essentially?
Yeah. And the whole thing was like built on. It wasn't like a rigid structure.
What?
So wait, I'll just tell you how the engine works briefly. So it does all those fusion reactions, like I was saying. You put in the antiprotons.
Yeah.
But then, as you get to a point where the thrust that's coming out of that it only gets to about the same speed as the other one. So it gets to like 12% the speed of light or something like that. Then you start doing pure antimatter reactions. Right. Which is that like spikes the increase in the amount of antimatter you need. Yeah. To get you up to like 93% the speed of light or something like that. So really fast.
That's amazing.
Yeah, well, but obviously it's antimatter, so it's not going to happen for a while, if ever. And consequently,
fucking fast though.
You can get very, very fast, but there's like obviously huge technological problems because when you do like antimatter reactions, you have shitloads of radiation, like loads of radiation coming out of the engine essentially. So you have to have the crew module like 10 kilometers away from it.
Jesus Christ!
And because it had to be
like
so spread out,
yeah.
And with like a, I think they were thinking of using. Was it tungsten? I think it was like a tungsten shield behind the engine to block off as much radiation as they could.
Jesus.
But the whole structure wouldn't be rigid. It would be like tethered together.
So it's almost like it's weirdly like a hot air balloon kind of like idea where it's all like ropes and like tied together.
And you have it like I don't quite know
like a space version of that.
Yeah. And then to like turn it, you'd have to like rotate everything at once. And if you had like something slow down at the front, everything would have to crash into it.
Yeah.
So there was lots of weird problems with that. But it was a cool idea in terms of the sort of like dual antimatter fusion drive, which maybe could work.
Yeah, with revolutions in producing antimatter, being able to do that more cheaply.
Yeah. And the other cool thing was that they because there's tons of like waste heat produced, they'd have some sort of bizarre cool system where they get loads of liquid, heat the liquid up, and to dump the heat, because it's very hard to dump heat in space, they'd fire all the liquid in front of the spacecraft, like, and then which would eventually lose some of its momentum, apparently. Or the spacecraft would eventually catch up to it because it's increasing in speed.
Right. Sure.
And then recapture that liquid because it would have cooled once it's been sprayed out forward. So you keep losing all this heat by spraying all this liquid out and dropping back and catching it back up. It was a totally mad idea.
Yeah.
But
it's just with all these things, you just have to. There's so many like hoops to jump through. It's like right, okay, now what we'll do with the liquid and the heat. Right, okay, well, maybe if we do this, it would work. Or like maybe if you like have a station at Jupiter harvesting. All these kind of like things you have to think of and like hoops you have to jump through.
So all these things are like designed. So what's really good about antimatter drives is that you get a very high energy density.
Yeah.
So like chemical rockets, you've obviously got, like you can't store that much energy,
right?
Because antimatter is so explosive. You get basically from the mass an antimatter particle is, and the reaction with matter, you get a lot of that mass back as energy. So you end up with a very high energy density.
Yeah.
which is great, which means that you can end up with, instead of something like 46,000 tons or whatever of fuel you have to take, you can take like to transport like 100 tons or whatever it is, you can, I think it's about 2,100 tons or something like that of fuel per 100 tons to get it to...
That's way better.
Yeah, which is way better.
Way better.
But obviously, like, ludicrous, because antimatter is so difficult to produce.
Yeah.
And, it's totally ridiculous to try and...
Yeah.
Now, anyway. So, to have a spacecraft that can continually accelerate without a propellant is like... It seems like, well, it's supposedly an impossible goal.
Yeah,
because
sure.
It's supposedly...
On the face of it, it seems like it violates one of Newton's laws.
Exactly. But people have been claiming there's a bit of a stir that's been going on recently in actually a few different places, not just the original inventor Roger Sawyer, who I think is a UK bloke.
Yeah,
from the UK,
I think so. Yeah.
Who kind of came up with the idea for the EmDrive.
Yeah.
And they're starting to research it in China, in NASA, Eagle Works, various other places around the world. But it's highly controversial. Most physicists just think it's bollocks.
Yeah.
Like total bollocks.
Yeah.
And that it's impossible. And it's
sort of something that's come through experiment that we don't even really have a theory to explain what's happening. Like you wouldn't be able to predict it so much. Like it's just sort of was it originally predicted through theory, or was it just like like, oh shit, we just built something that does this, and what the hell's going on?
No, the guy apparently was working on a project for the British military where they basically told them to go and come up with, like, think the impossible.
Yeah.
He ended up coming up with eventually this EmDrive system.
So it's M like EmDrive, EmDrive. Yeah.
And I don't know how he came up with it, because he seems to think he knows how it works.
Yeah,
and explains it in a like slightly confusing way.
Yeah, a lot of people think it's just total bollocks, don't they?
Yeah, it's complicated because he built a working model that seems to produce thrust, and loads of other people have built working models that also seem to produce thrust, and it's getting to the point where something's happening and no one can quite nail down exactly what's going on.
And it's quite it's quite simple, the design of it, isn't it? So people there's like YouTube videos of people like making DIY versions that you can like supposedly see on the video, then measuring like a tiny
Apparently
amount
that's
of thrust.
quite dangerous.
Is it?
Yeah, because you've got to put quite a lot of microwave energy into it. So it works by kind of emitting microwaves into a sort of tapered cavity.
A bit like a cone, like a cut off cone, right?
Yeah.
So like one end's wider than the other.
And then it does something that no one really understands.
Somehow moves.
There's some sort of resonance
thrust.
thing that somehow causes a pressure gradient or a pressure, which induces a thrust.
And this is like the holy grail. I mean, we've been talking about all these different mental ways, like exploding nuclear bombs and antimatter drives, all require like a shitload of propellant.
You can forget all that. You don't need that.
You don't need that. You can accelerate. You can create thrust. You can accelerate whatever. You can travel at great speeds, at great distances, with no propellant.
Yeah.
All you need is power, that's the holy grail. So if it does work,
it's like totally off. It's like jumping ahead, way too far ahead, much further ahead than we thought we would be jumping. If it's true, further ahead than we thought we'd be jumping, even in the years when we'd be able to produce like antimatter en masse. But it's like it can't be true.
Like surely it's not true. Surely there's like some. So all these experiments, I was aware. I thought they were like the amount of thrust they're producing is absolutely.
Yeah, it's like 100 micronewtons.
And some people think that this is experimental error, or that it's that they haven't controlled for some factor. But it has been reproduced like widely, right? More and more people are reporting that they've reproduced the same kind of like tiny little thrust from these things
exactly
consistently.
Yeah, I mean they're working on it in lots of different places. But one of the guys working on it at NASA Eagle Works has been like writing on forums, kind of keeping people up to date. So there's not actually like a published paper on this current work at the moment from them.
Yeah,
and that's just because they haven't finished the work they're doing.
This is what created the massive buzz about it a couple of months ago.
Yeah, exactly.
Was this post on like a forum?
Yeah, he's been posting regularly. He's not just like a post, and he replies to comments and things, and basically saying that they are controlling for this thrust they're finding in this particular setup they've got with the EmDrive. in a whole bunch of different ways. They're doing this and that. There's a few things left to kind of pick off the list, but actually, they'll do things like, for example, the shape of the if they take the conical shape off the apparatus, it doesn't produce any thrust anymore.
Right, that's mad.
And it produces thrust in both like directions. If they like turn it, it will produce thrust in both directions, like
so the opposite direction.
Yes.
Yeah.
And the more basically that it doesn't make any sense that it works. Okay.
Yeah.
But they can't get rid at the moment of the thrust they're seeing. They're trying to like cut everything out.
Yeah. And I think on the forum, one of the reasons because people were coming back to them, it's like, oh, you haven't tried this. Like you need to make sure that you control for this. And they go back and they do it, and they still measure the thrust. Exactly,
but there are still things to cut off. And they've been talking actually recently about. They haven't got the budget for it at the moment, that particular group, but I mean, maybe they will have it if they get through all these other controls, to put it on like a CubeSat and stick it up, like a model of it, and just see if you can just like fly it off.
Yeah. See you later.
Because if it works in space, if it just works and starts producing thrust,
like
doesn't
matter how tiny it is,
yeah,
it'll gradually accelerate faster and faster and faster. A bit like the iron thrusters, like an even more like ridiculously low thrust version of that.
And so, maybe they'll be able to do that and see. And I mean, we'll find out. It's potentially exciting. It's easy to get very, very excited about it, and people are getting very excited about it.
Obviously, extrapolating it like to ridiculous things.
Well, there are some actually slightly ridiculous things that Roger Sawyer's claimed with it. He says that there's like a generation 2 that he's come up with, which is like has a superconductor on it. To produce the microwaves, which means you can produce a lot more energy, it doesn't get as hot, etc.
Yeah.
That you could use to produce a craft that would do a single stage to orbit from Earth.
Huh. What?
So actually work in atmosphere.
So no rocket propeller. You don't need to lift it with like a heavy lift rocket.
No.
It literally just flies into the air.
It just has like 4 or 7 or whatever these EmDrives and flies out of the Earth's atmosphere in a vertical, like a VTOL thing.
I mean, that's literally like something out of Star Wars. It's like total science fiction. Just a thing that just goes like and just flies off.
And just flies off into space.
Yeah.
And then can accelerate to whatever speed you want.
Yeah. That is nuts.
And then can decelerate,
But the guy, I mean,
and it's worth saying as well.
He doesn't make a lot of sense sometimes, from what I've seen.
Yeah, I mean, he's obviously, he's not just a crazy guy.
Craziness.
He's definitely not a crazy guy.
It's not total craziness.
He just very much believes in his kind of invention, and it's one of those things of like, is it a pet theory? Possibly, but then no one's been able to rule out the thrust that they've seen. So like I wouldn't go as far as to criticize him for pursuing something that he can't control for.
Yeah,
like as in he's discovering something, he's tried everything he can, and he can't get rid of the thrust.
Yeah,
everyone else is doing the same, and they can't get rid of the thrust.
Yeah,
so it's like you want to try and promote that idea because you want to understand if it's something amazing or if it's just a waste of time. You need to have people test it out.
So presumably, if it literally does work as like a cavity that you somehow resonate microwaves in that creates thrust, then there's no reason why it shouldn't be able to work in atmosphere and out of atmosphere.
No, I mean, like you see on YouTube, you see a very small amount of thrust being produced in atmosphere happily, but it's a very small amount. But he says you can produce a lot more thrust with a better setup, essentially.
Sure. And if we can confirm that it works and crucially how it works, which might take a little bit longer, because it's one of these.
There's no explanation for it at the moment.
Which is one of these weird situations, which I guess used to happen, especially in physics, a couple of hundred years ago.
A lot more often.
More often, and now most physics is underpinned by theory
before it gets discovered.
Before it gets to experimental stage, like the Higgs boson.
Yeah.
Although,
and recently they've just potentially discovered, it's not confirmed yet, looking more and more likely that there is another particle they've discovered that wasn't predicted by the standard model.
Yeah, so that's
comparable.
That's comparable, and maybe this is just we're actually just moving into a new phase of like experiment, where experiment is driving theory rather than theory driving experiment.
Maybe.
In physics. And this is like another example of that. Just some like weird thing that isn't fully explained at the moment.
Well, the thing with physics at the moment is that it's slightly stuck in the sense that, like, they keep confirming the standard model. Everything just keeps confirming the standard model,
which
we know doesn't make any sense.
Yeah,
like as in we know the standard model does. the standard model doesn't explain everything,
Yeah.
but the more we understand about the universe, the more it seems to validate it. And it's like so we're looking for a surprise in order to change our direction with physics.
Yeah. That's what the LHC is doing at its high energy sort of operation.
And they'll,
and what the Chinese are going to do when they build their absolutely giant accelerator that they're building.
Yeah.
That thing's going to be huge.
Yeah. I mean, we'll see what happens to that when their economy's in trouble at the moment.
But what I was going to say about the EmDrive is is once we understand how it works and can confirm that it works, we'll start to be able to refine, like, okay, so maybe if we tweak this, we can get more thrust, and maybe if the shape's tapered a slightly different way, then once we understand how it's working, you'll be able to scale up from like the tiny thrust you get now to like actually usable like spacecraft.
Yeah, but the majority of scientists think that it's not. It's basically just going to be an experimental error.
Yeah, that it's going to be explained away by something.
That actually there's no thrust produced with the microwaves that are being emitted, and it doesn't mean anything. And obviously that would be disappointing, but it would be similar to something like, do you remember when the neutrons were said to be going faster than the speed of light?
Yes.
In Italy.
Everyone got really excited about it.
Well, yeah, there was some public excitement.
That's what I mean. Yeah.
But most of the physicists working on it were just like, it's probably an experimental error. And it turned out someone hadn't tightened a knob somewhere on a wire, and it was giving them false readings.
There was a great paper. Obviously didn't read it because I don't understand that kind of stuff. But there was a paper that I saw because the abstract for it, like the little summary of the scientific paper at the start, the title was like, this is a total colloquial translation of the title. It was much more like technical than this.
Sure.
But the title was basically, did the neutrinos travel faster than light? And the abstract was, probably not. And these things are usually like 200 words, like talking through the results of the paper.
In a really like professional, boring kind of...
And the abstract was literally just, probably not. Which I thought was pretty good. Yeah. Because, I mean, you
get the odd bit of humour in papers occasionally.
Sometimes.
So we'll see with the EmDrive. It's going to be something to certainly everyone to keep their eye on, but don't be surprised if it turns out to be absolutely nothing.
Yeah. But anyway, so even let's say that it does work, absolutely works, nails down, and we can build something that is really high thrust out of it, and it revolutionises everything. It's still speed of light, right? So that maximum you could travel is very close to the speed of light.
Theoretically, if you have just electricity powering it, no propellant, and you generate your electricity from the stars around you, etc., or on board with a nuclear reactor, you could go on forever almost.
Keep accelerating.
Keep accelerating, but you cannot go faster than the speed of light.
Yeah, so
in a relativistic world, in Einstein's world.
Yeah, which is apparently what we live in. Like that's
seems to be yeah.
So because it has mass, it can't. So you could continuously accelerate, but the closer you get to the speed of light, like
you basically just can't get there.
You can never get there. So even with that,
so it's still
going to take 4 years to get to the nearest star, and like 100,000 years to fly across the Milky Way galaxy.
Exactly. So
we're still stuck with the same problem of long duration space. Like if what we want to do is explore the galaxy and sort of colonize and spread throughout the galaxy, we're still stuck.
Closest star is 4 years, so 8 years there and back, maybe a year in the system.
And that's the closest.
So that's a 9-year round trip potentially, or 10 years probably, or something like that for a human crew, which is incredibly long.
And there's not anything that interesting about our century. What we really want to do is go to like some of these sort of mental systems we've discovered with maybe slightly Earth-like planets.
Exactly.
That's what we want to do, and they're thousands of light years away.
Yeah. Well, I don't know what the closest one is, but
but they can be.
Yes.
Many. Like,
I mean, certainly tens,
hundreds, whatever. Long way. So what we really want, and this is like the realm of science fiction in some ways, is to be able to travel faster than the speed of light.
Like those neutrinos.
Yeah.
So
that's what we want. Right?
Ideally.
That's the dream. Like that is the way in which we would become truly interstellar, right? As a species.
Yeah.
And colonize the galaxy. So if we could travel faster than the speed of light, because then the same crew could travel across the galaxy and wouldn't have to go like give birth to the next generation, etc., etc. So is that possible?
At the moment, obviously, physics says
nope.
It says no without some sort of manipulation of space-time.
Yeah.
And actually, there has been some stuff that's crossed over into the news recently about the EmDrive.
Yeah.
And a warp bubble, which has probably been, slightly, I'm sure has been overhyped, etc., etc. And Roger Sawyer says, but people have asked him, is the EmDrive does it create a warp bubble? Does it, go faster than speed of light? And he just says no, nothing of the sort. But
there's a weird, and this is again another example of like a completely like unexpected result from experiment that was never predicted.
Yeah, and again, a very early experiment.
Oh yeah.
Not
conclusive.
Published, not conclusive.
In any way.
Again, a slightly odd result, a very odd result.
Possibly, and almost certainly just going to end up being explained away by some kind of weird experimental error or something they haven't controlled.
Something mundane, probably.
But some scientists at NASA EagleWorks, which is like NASA's like advanced space propulsion laboratory.
Yeah, where they're looking at the EmDrive.
Where they're looking at the EmDrive, and they're also trying to work on this warp bubble thing. Which maybe we should just explain what that concept means before we dive into the EmDrive stuff as well. So the concept of warp bubble is a way of sort of sidestepping the theory of relativity. So instead of traveling faster than the speed of light, you bend space-time around you in such a way that you contract space and expand space. You contract space in front of you and you expand space behind you, which means that you effectively move from one place to another faster than light would move. But the actual space you are contained in is this like bubble in the middle of space-time that's being distorted, which you're not actually traveling through space faster than light. It's just that you're basically being pushed, squeezed by contracting space-time, essentially. And we know that's possible because space-time did expand faster than the speed of light during inflation, which is right after the Big Bang, like billions of a second after the Big Bang. We know that happened, so it's possible for space-time to distort faster than the speed of light. And if you look far enough away, you're looking really far back in time, obviously, because light has taken a long time to travel. If you look far enough away, the edge of the observable universe essentially corresponds to a region beyond which the universe is expanding faster than light travels. So that's why you can't see it. So you're looking so far back in time, you're looking at that point of inflation. So that's like forever dark because space is expanding faster than light's traveling through it. At that point.
Which again, like that's something moving faster than the speed of light, but it's not violating any of Einstein's laws.
It's space-time itself rather than matter.
And with the warp bubble is a similar.
It's a similar concept.
Analogous.
It's exploiting that. So it's being able to actually like bend and distort space-time. That is mental. It's crazy. I wonder what that would look like if you were on board a ship that did that.
I don't know. You probably get some weird like gravity lensing.
I'm gonna be honest. I'm imagining. You know when they go into like hyperdrive or whatever in Star Wars, and you get all the stars going like, that look.
I mean, if you're going far, maybe maybe you wouldn't be able to see out of it. Maybe you wouldn't have like light coming in and out of the bubble.
I think what would actually happen is, maybe not. I was gonna say like things would get like horrendously like blue shifted or something in front of you, and red shifted behind you. I think people actually even talk about the blue shift effect would be so extreme that it would be like horribly dangerous, like UV and X-rays and shit, like tearing you apart.
Oh, yeah.
That's something that people have said that might be a problem with it.
Jesus, that's really cool.
But anyway, so that's the concept of a warp bubble, and people reckon that it's possible. Like it's mathematically possible to do that, and I don't understand how you go about warping space-time. Apparently you need like an incredibly high amount of negative energy, which is a thing. Right. I guess it's a bit like antimatter.
Okay. You need something that deforms space-time in a certain way anyway, on both sides of it. And and that's obviously like far future, like crazy sort of idea. Except they're actually trying to measure it.
So this guy at EagleWorks, that NASA lab I was just talking about, Harold Sonny White. So he's like the guy for this at the moment.
He's the man of the warp bubbles.
And he reckons
you want warp bubbles.
He's your man. Give him a call. So he reckons that you can, if you do something to. So the original theory of this called for like an insane amount of energy and mass that was just unfeasible. It was like multiple times the amount of mass and energy that exists in the universe, whatever. But this guy's like, okay, if you change the design of this thing a little bit, you can actually reduce that to like manageable levels, and he's trying to prove on like a benchtop lab experiment that you can warp space-time, and he's using some like setup with lasers to like measure the distance that light travels and try and change space-time. Anyway, so because they're all working in the same sort of building, I guess EagleWorks is these people working on the EmDrive, and NASA and these guys, they decided to stick an EmDrive prototype in this instrument that they have designed to measure warp bubbles. And what they found, really crazily, was that in the chamber of the EmDrive, this like conical chamber where you fire microwaves around, you actually get exactly what you'd expect happening if there was a warp bubble forming in there. So like they have like 2 laser beams and they're exactly the same length, but the time it takes the light to travel across one of these beams is slightly longer than the other one, which is what you'd expect for if space-time had been warped in the middle. So it's traveling through like some weird thing in the EmDrive, which is causing the light to change speed essentially.
So is the light traveling faster than it's like? Is it traveling faster? Or is it? Like
I don't know if it's traveling faster or slower, but whatever it's doing, it's arriving at a different time than you would expect. And one of the ways to explain it, apart from like crazy experimental errors and stuff, is that space-time is warped in such a way so that it's essentially traveling over greater or less distance because there's this like warping effect.
So it's like, I mean, that's absolutely like that's crazy.
It's like here are 2 completely thought to be completely separate, almost like science fiction. Advanced propulsion ideas. EmDrive, warp bubbles. No one had any idea that they might be linked in any way at all. Stick them together in the same experiment, and it seems like one of them, the EmDrive, is producing exactly what you would need to drive the other one. Like, total head fuck.
Yeah, but it's got to be wrong.
But it's got to be wrong, yeah. It's got to be wrong.
That's the presumption, is that it's not.
I think one of the main leading theories is that it's something to do with like temperature change inside the EmDrive cavity. But then Harold Sonny White, I mean, I just read all this like recently. Yeah. He was saying that actually like the amount of the difference in light arrival time that you see can't be explained by the temperature difference. Like that doesn't quite explain it. There's other things going on. But anyway, so I think again these aren't confirmed. These are far from confirmed results. You know, they're just like popped up on a forum again. Like these people are obviously working on it and they're going to try and knock down all the possible explanations to get to like what's actually going on. But it's just crazy, like coincidence that these 2 mental sort of technologies.
It's just cool that it's being developed and looked at.
Yeah.
Even though it's probably going to end up being nothing. But I mean, obviously, you don't. This is the great thing about doing science properly is that you be very open-minded and you try these things. Yeah. But you never have like a pet theory and you just try and ram. You know, you just keep going on the same thing when it's clearly wrong. So once you when you knock down all the possibilities. And you end up with just that one answer. That basically what this needs. This is an extraordinary claim. It needs extraordinary evidence.
Absolutely, yeah.
So then, if they knock down every single possibility, then they're going to need to build a working prototype that they then demonstrate to work in space, and then demonstrate to work to like whatever speeds or whatever.
Yeah.
And it will just, if it's true, that will come out of the work. And if it's false, it will be shown up eventually because it won't work in space when they actually build a working prototype. So they'll need to go back to the drawing board and try and explain what they were seeing on the ground.
So if I'm honest, I fully expect that experimental weird like blip they discovered with the EmDrive and the warp bubble like measurement stuff. I fully expect that that's just going to be explained away by some kind of like weird experimental noise thing. Like that. Honestly, I mean, it would be cool, but.
Yeah, particularly the warp bubble part of it.
Yes, but the EmDrive itself, though, like I'm not so sure about that because just because of the kind of the weight of I wouldn't say the number of groups that seem to be reproducing that little sort of evidence.
Yeah, I agree with the warp bubble thing. The EmDrive thing it's just slightly more intriguing.
Yeah,
it's slightly more believable. There's basically more data backing it up from multiple groups. It's just. There's no reason to think that it's still not just a data error, just a continuous error that's happening with all the groups. It just seems less likely.
Yeah, I mean, it's totally possible. I mean, they're all essentially performing the experiment in similar ways. It's possible that they're all building in the same error somehow.
Exactly.
But, you know, time will tell, and these things will continue to be refined, and eventually, hopefully, we'll have an answer in one way or the other.
Yeah, exactly.
It could be, like, a massive deal.
Yeah, exactly. It could be huge. I mean, if the warp bubble thing is real.
Yeah. Oh, yeah.
Then, I mean, that at this stage in our sort of civilization, that has like huge implications, right, for things like the Fermi paradox.
Yeah.
Because if we've already discovered, so this is like totally hypothetical now because it's probably not real.
Yeah.
But if it is real, we've potentially already discovered a way to travel faster than the speed of light.
Yeah.
Or in which it could be developed into something to do that.
Yeah.
we don't know the effects. It might be that actually we develop something that we can travel faster than the speed of light with, but it like kills you. Like, and you can never. It's like yes, you can do it.
You can't actually put a living
but if you put a person
inside.
in it, they just get fried.
Yeah.
By
you could send an object, but even if you could send an object, you would expect that like because we've as a civilization we've only been around for like 10,000 years or whatever, like not very long.
Yeah.
So like any civilization that's been around in the galaxy for that long or longer, if we've got to the point now where we're just sort of discovering this, you'd expect them to have discovered it and to use it. Even if they can't send their like biological sort of beings and stuff via this method, they'd still be able to send probes and all that kind of stuff.
Yeah, provided things again. We don't know what.
Yeah, true.
I mean, potentially nothing can survive in that like warp bubble.
Yeah, that's true. That's true.
It just gets stripped of everything. It gets like totally like turned into plasma, and then when it comes out, it just vaporizes.
Yeah. Okay. So if that was the case, then that sort of it's then impossible to travel faster than the light.
Yes.
Yeah. So the two possibilities are, so the lack of like seeing like faster than light traveling aliens, like galaxy spanning aliens, could either be explained by it's impossible to travel faster than light, and civilizations end up sort of discovering that. And sticking to their own systems and like, okay, well, we can never really like fully explore the galaxy, but we'll just like exploit what we've got and develop here. Or it could be that we're super rare and like the Earth is like the only civilization in the galaxy.
Yeah,
those are sort of the two outcomes of that, right?
Yeah, I think so. And I guess aliens. Yeah, we just it's just one of those things. It's like you're never quite sure. Obviously, if we discovered a warp bubble and it works, like it's a thing that we can actually use. Then the fact that we haven't seen any aliens yet suggests, like you say, either the rare Earth thing or we are rare, or well, I guess there's still other, but there's possible like great filters. So, civilizations die out really quickly.
Yeah,
these
true.
Types of things, but you'd expect them not to die out quickly if they've got access to speed faster than
you would.
light
You'd be expecting them to like spread themselves like over multiple systems to like mitigate the risks of catastrophes.
Just existential risk.
Yeah.
Get rid of it. Yeah, that's true.
So out of those two scenarios, it's a bit of a weird question, but like, would you rather live in a universe where we are super rare and even possibly like the only or the first civilization, but faster than light travel is possible through something like this warp bubble thing, or would you rather live in a universe where there's loads of civilizations, but faster than light travel isn't possible? And we basically can't have like a galactic civilization because we can never really, you can't travel like to a star 1,000 light years away. You can't even send messages because things are limited by the speed of light. So galactic communication and interaction is sort of not possible ever. Like we know they're there, but it would take thousands and thousands of years to even send a simple message back and forth. Which of those two scenarios do you think is?
So you know that So you know that probably the first one, because like in the both scenarios, a galactic like me or like the human in the first scenario, the human race is going to take a very long time to get to a point where it could be part of some sort of like awesome galactic civilization that travels around, etc., because we're super rare, and we're waiting for other stuff to develop to that point. So we may not last.
Say we're like
that
one
long
of the
either.
first.
Yeah. That's sort of what you mean.
I guess so.
In the second one, so it might take us a while, but potentially that could happen, right? That we could come into contact with aliens. We could have this awesome like interstellar.
And by that point we'd be
organization.
Like we'd have faster than light travel.
Yeah, we'd be like the lords of it.
We'd be the bosses of the universe. We'd be dominating everything.
Yeah. Okay,
we've been around for a long time, and we have like we're super advanced.
In the second scenario, though, there's no hope of that ever happening. Anything cool like that ever happening? We're just sort of stuck in largely in our own system. You
might find that there is, say, the galaxy's teeming with civilizations, but it's all limited by. You might find that we do find ways not around it, but that some sort of rudimentary society evolves that somehow communicates on 1,000-year or multiple thousands-year timescales somehow.
Yeah, that's true.
But
it's not as exciting, is it?
It'd be lame.
I mean, well, it'd be awesome, but like it's not what I want. It's not what I want.
No.
It's not ideal.
I want to be
So the first one.
Yeah. Okay.
Definitely the first one.
Yeah, that's fair. But I mean, we have no idea, so we'll wait and see to find out.
Yeah. So I think that's most of the stuff I wanted to talk about. You want to talk about anything else?
I don't think so.
Cool.
No, I think that rounds off our little topic nicely.
Awesome.
Yeah. So just before we go,
Final
it's time for Nutters of the Week.
Oh yeah.
So I've got a little
turn.
story. I'm going to bring you to this week, everybody, the story of the town of Woodland, South Carolina. The town.
Is this like a ghost story?
Better. It's better than that.
It's better than a ghost story.
It's better than that.
Right.
It's a real life. This is some real worries that these people are communicating. So basically, there was some plan to like build a solar farm. So like an array of solar panels near this town, Woodland. It's like a small town in North Carolina. North Carolina? Yes, North Carolina.
Solar panels.
Solar panel, massive like array of solar panels. To basically to power the town and to like supply energy to the grid and all that kind of stuff. Totally reasonable, good thing to do. Whatever. Right. But they let it open to like a vote for the town council or whatever. These people were allowed to decide whether they wanted this happening near their town.
Right.
And the people were kind of like figureheaded by this person who's like a retired science teacher in the town. So she was the kind of spokesperson.
Okay, a science teacher.
A retired science teacher, and she was dead against it and managed to get the vote passed against the building of the farm. And the reasons are.
Oh, so I'm thinking. Normally, I'd think they don't want it because it looks ugly, or
something like that.
They don't want to. I don't know some reason, but because it's in this segment, I'm imagining it's not just because it looks ugly.
It's better than that. It's brilliant. So the reason
solar panels. Well, yeah. Okay.
The reason she didn't want them is because she thought that and she convinced everybody as well that they were going to suck power from the sun and stop photosynthesis.
What?
And first when I read that, I was like, maybe she means like there's going to be plants underneath the solar panels that are going to die. But no, she means that she reckons that all of the plants in all the farms in the town and around the town are going to be depleted of solar energy because of the solar farm sucking up the solar energy.
But they're not like a giant vacuum cleaner for the solar energy coming.
They're basically doing what plants do in a really sort of roundabout way anyway, just sitting there. But I mean, she went on from that. She also said that nobody can tell her that the solar panels.
This is a science teacher.
This is a science teacher. Nobody can tell her that the solar panels don't cause cancer.
What does she mean?
Right.
Like producing? She doesn't mean producing them. She
doesn't even know what she means. I don't think
that they reflect more. They're more absorbent than normal surface. What?
This is a quote. I want to know what's going to happen. I want information. Enough is enough. People come with hidden agendas. Until we can find anything is going to damage this community, we shouldn't sign any papers. And the way she thinks it's going to damage the community are through depleting solar energy and killing crops and causing cancer. Or at least not. We can't say at this point that they're not going to cause cancer. So the town voted against it, and so there's no solar farm in Woodland, North Carolina, because of this.
I don't understand. I don't understand how a science teacher can think anything like that. I don't understand like where you get that view from. Like there's no like teaching. I can't think of like a sort of I don't know, a dogma that she's attached to that makes her think these things.
I know.
The only thing I can think is that she's just stupid.
Just stupid and thinks she might have some kind of like voice in the town and is like wielding it because she enjoys like the kind of position of power or something.
I don't understand how you can like come to that conclusion based on
like anything.
There's no. I don't get it. I do not understand how you can come up with that.
So she said she was concerned about the rising.
It's absolutely brilliant.
I know it's good. I know it's great.
What the hell?
I mean, it's sort of hilarious and also kind of scary that someone who's a science teacher can have those kind of thoughts.
Is it like science teacher in like she's teaching? What sort of science teacher are we talking? Are we talking like a?
I don't know. I don't know enough about North Carolina, but I know there are some states in which like science is not taught in the way that we would think of science.
Yeah, but that the thing is, what she's expressing there is not.
It's not like religious.
No,
it's just totally wrong in every way.
It's just like a fundamental misunderstanding of just like really super basic kind of physics and just the relationship of normal scale kind of she doesn't need to know anything complicated or have learnt a very basic education. You would not be worried about solar panels sucking in the fucking sun energy.
I mean, it's brilliant.
It's absolutely ridiculous.
It's
brilliant.
Pure gold. Yeah, I love it. I want more of this kind of stuff.
Well, yeah.
Thanks, Woodland.
we do want some. We keep the fodder coming, but also that's kind of awful.
It is terrible. Yeah,
that someone like that has influence.
Yeah, that's the worst thing about it. If it was just somebody like saying that on a website,
that's worse than
that would be purely funny.
That's worse than last week's mental timekeep thing.
Yes, because that was just somebody on a website
going a bit
talking nuts. Whereas this person's actually had influence in like the decision of a whole town. I mean, it seems kind of trivial on the face of it, but like, you know, we need to transition the world away from fossil fuels. It needs to happen. So people like that are just going to stand in the way. It's unfortunate they have influence, I guess.
That's so funny.
It's also great.
But the reasoning for it is so ludicrous. Like, anyone presumably outside, with any proper influence, like real influence on the world, is just going to
yeah. They should just build it anyway.
Yeah, they should.
Yeah, absolutely.
Like, that's not a reason.
No.
Like, you might as well, like, if someone might have come into that room, right, and just hit like a saucepan on their head and walked out. That is as much like you take that as seriously as what she said.
Yeah.
That's true. It makes as much sense.
Yeah, absolutely.
As an objection to building a solar farm.
Yeah.
Anyway, very good. That's a good night of the week. I like it. Very good.
We're raising the bar. So
we'll have to find something next week. We don't really know what we're doing next week.
We don't know what we're doing next week, so we'll wait and see.
Yes.
But until then, if you want to get in touch, as always, comments, email offworldempire@gmail.com. And yeah.
Thank you very much for listening, as ever.
Definitely. See you next time.
See you. Bye.